Alright, we're moving back to the lathe for our project now. We've got the gear and the blank. We've got them to where they match the bores. We have a keyway in them. And now we need to go ahead and make a mandrel shaft or a stub shaft, an arbor, a couple different phrases you probably use, to drive this assembly for two places. We're gonna do the finished OD turning in the lathe, and we want to do it between centers, and we want to go ahead and take it from there over to the mill, and we're going to turn it with a center and then in the precision chuck, rotating it around, making sure that it is running as if it was running between centers. And we're going to cut the gear teeth in it. So this is basically going to be another tool to do the job. This is 12L14 I'm going to use. We're also incorporating a National Fine 1-inch nut, which will draw it down and hold it against a shoulder. We will go over to the mill and we put some kind of a key in it, whether it be a Woodruff key or something like that, that we can just slide it right on. Now, I want to turn this between centers, and this is, you can do a face plate or a dog plate and then put in your centers right into the spindle. I have that accessories there, but there's a most common, I don't get into changing out all of this heavy stuff here. I just go ahead and I chuck up on a dummy center, making sure that it's secure and everything, and then take a real light skim cut on it to make it 100% running true with the axis of the shaft. And that's usually how I create the center on the spindle end or the chuck end of the project when I'm turning between centers. This one, over the years, this flat on this OD right here was about that long, and over the years of skimming it each time, it's gotten shorter. So what happens is your dog moves back into here, pretty soon you're up against here, and or running this out farther onto your part. What I want to do is go ahead and I'm going to turn me another one of these, and I'll show you how I go about this. I'm making this out of a piece of Aquamet 22, which is pretty tough stuff. It's really excellent as far as turning. You get into threading, drilling, and things like that, and then you're into a little bit tougher machine mode, but it does turn fairly comfortable, I should say. It's not the easiest stuff to cut, but it does, and it has a real nice finish, and you don't have to work real hard to get the finish. Alright, and you'll see that in the cutting as well, just like the marine shafting and stuff like that. Alright, basically I'm going to duplicate this. I like this length of shoulder here. I got a little 3-inch plus. You can see I originally made it off of a chunk that I had laying around, and I wasn't really trying to get it nice clean. It wasn't a piece I cut intentionally to make this part, because back then I was scrounging anything that I could to make anything I could. And then this is just the angle. This diameter here, I picked this diameter, and what it is this is done so well over the years. I had pretty well searched out, and I found something that's very comparable to the same diameter, because this kind of fits into the play of most of my dog configurations and the distance in, and the position it holds, and the chuck and the jaws there. The bigger this is, the farther out the chuck's jaws are going to be, and then vice versa. If you go in too far, you might actually be holding something out here, and then your dog or the finger, and actually I welded this on here because the original one wasn't long enough to do the job. So anyway, let's go ahead, and I'm going to move this stuff off of here, get a bit in here. We're going to turn a shank down to this diameter here, and then we're going to go ahead and part the thing off. Then we'll turn it around, and then we're going to create the point that we need to use as a center. Okay, first off, this piece was cut off with the parting tool. So the parting tool comes in and it leaves a little nub right there. This isn't very much stick out, but I want to go ahead and I want to throw a center in there and then bring my live center into it. So I'll put a center drill in here, but before I do that, I want to go ahead and face it off so that we're not going to be coming in on top of something to try to put a precision center drill on the end of this. normally have this one set here, but I've been using it in another app thing and I haven't reset it, so we can lock that now that we know that that's on center. You know, I think I probably even remember asking, hey, how big do you make that center? And, you know, the main thing is you don't want to go past the major diameter of your center, because then you're going to be putting a shoulder in or a countersink before you get to the center, and it won't work. So the size of that center is relevant to your project. This is, I think this is a number 4 center. It's not a very big center, but it's more than enough. And this is probably half again as much bigger center than I actually need to do it doesn't take that much to hold steadiness to the end of your part or support the part. This is probably the average size for, you know, up to things that are 3 inches in diameter and a couple feet long. You know, you might want to put a larger one in. It depends on what you're doing with your part too, as well. As if it's a small nub sticking out here and you're going to have a real thin difference between the OD of your center and the threads or something like that, you're going to want to keep it small and minute. If your center comes in and you need to have more room between your live center or whatever, and to where you might be coming in with a pointed tool bit in here, okay, you want a smaller center if you can get by with the support you need. So back to the original question, how big should I make my center? That's a variable that you got to kind of work out and plan out with each individual project, I would think, or I feel. Alright, we brought our live center in here and we've got our insert set up and we're at a slight angle, so we're going to be having a leading. We're not coming into a square. We're not going to be able to create a square with the angle that we have our tool bit here, but we're going to go ahead and rough this on down to a distance here, and then we're going to come in with another tool and we'll go ahead and we'll face that off and put a slight little bit of relief in there, so that, I mean, there's an angle on these jaws here, but it just gives a polite little radius and finishes off the shoulder we're going to have on there. This diameter, actually, the diameter of this original piece here was like 1 5/8, and this right here happens to be part of the wing it shafting job, which is 40 millimeters or 15745. This shank right here, I actually turned this down to like 1/400, and I'm going to go ahead and turn it to 1 3/8, so I'm going to be shooting for 1 3/8. Not that it has to fit anything in particular, it's just going to be going and it'll be chucked on time after time after time. But in the relationship of this diameter to this shoulder, the same thing on this, I'll do that. Alright, and we're gonna go ahead and create about 3 3¼ inch on the overall length there, and we can just put a Sharpie and we're going to cut right into that, down to that Sharpie's length on the shaft there. Okay, this kind of a finish right on here, I know is a sign that this insert is starting to get dull. I've used these many times and I've cut this material many times, and that's what I know. So I'm going to go ahead and get my nozzle and a couple tools here, and we're going to index or change out completely that that insert there so we can get back to a good finish here. Okay, there was a slight little chip on there, and I turned the insert over. Sometimes it is hard to tell if you've already used another end because of the coloration, the blackness, and how long everything has been working on there. So we're just going to give this a shot here. We're about 1 inch 455, and we're just going to go ahead and take another 50 thousandths on here, so we got a relatively same cut that was there. We'll be real close to the diameter I was thinking about, and pretty close to a finished diameter. If we get a good finish on this, this will be the finished cut. Better. And see how the tips are breaking down here? And this is a good gloss. Add a little air, and then you can actually see how the tips fly away from there instead of being covered up by the smoke and debris there. Alright, I'm happy. I like that. Okay, we're going to turn our compound here, our tool post here, and come in here so that we can get a straight shoulder cut in there, and then take the DNMP right hand, put it in there, and break that edge right there. And we'll be ready to part this off to length, and we'll put it in the chuck, and we'll start cutting our point on it. Okay, sometimes you want to go ahead and you want to square your tool post, and I can take a square and bring it over here and go against this surface and stuff like that. How about being able to square your tool post? And there's a lot of different ways I like to square it off of things that are here. I square off a face sometimes. I can square it right off of the face of the my live center right here. I can square it right there. You can also, if you just turn the straight shoulder or surface in your part or whatever, and you're in the middle of it, let's just say the center's way down there or whatever, you can actually come in and go against the flat that you turn, and then you can lock your post in there, and now you're good to go. Alright, now I think I want to run a different bit in here. I'm going to go ahead, and we got a DNMP. There's a left hand here. So I'm going to come into the shoulder and then just give a little relief there. Just come in there and give it a little radius like that. Now we'll go ahead and I'm going to go ahead and use the same insert in a right hand. We're going to break that, and then we'll go ahead and break this one. We'll massage that a little bit with some memory in there. Alright, almost dropped my old center there. Okay, I'm happy and I like that. We're going to go ahead and change this over to our parting tool, and we're going to part this off I think actually we're going to slide it out and then we're going to part it off a little bit. This is our choice instead of going and putting this in the saw. Aquamet material is very rough on a saw blade. It doesn't take many of the shafting before you actually find yourself buying a new blade. Alright, that's running pretty true. Alright, we're already squared off of here, so we can go ahead and put in our parting tool. And I'm just kind of looking at where the point is and how long this shoulder is going to be from my cone. And about where it was, I'm not sure if I actually gave it about I might have actually given it an inch to start with. If I was going to guess that I was going to give it anything, I probably would have chosen an inch. And that's what we're going to go ahead and give it. Alright, now we're far up behind here. We're snug here. We don't need any feed. Alright, let's go. Okay, it's getting down close. I can hold it slightly off and let that break. Alright, it's a little bit faster than putting it in the saw and cutting it as well. Alright, now we can go put this in the material rack. We're going to move everything out of the way here. We're going to unscrew our chuck jaws off the scroll. We're going to blow it all out and we're going to put it all back together. One thing is our initial cutting and everything else on this, but I always try to keep the scroll clean because sometimes chips get behind them. And this is a real old chuck, and it makes a big difference if you got chips stuck into the scroll, and they do get there. And it's something that I clean out on a regular basis. It's probably about time to go ahead and pull the chuck completely apart, do a good cleaning, inspection, and put it back together. And then hopefully, maybe this winter I'll have my tool post grinder made up that I wanted to do 2 years ago, and we'll regrind some jaws. But until then, let's get back to our project at hand here. Okay, let's go ahead and I'm going to unscrew and clean out my jaws here, and there's my number one. I always like the number one hanging down here. The reason why I do this is the first one that lets go, and these will be loose to lift out, but because of the position they stay in there until I drop this one out and take care of it. Alright, now this is fairly clean. I did clean it not too long ago, but I wanted to make sure because of what we were doing to set up a brand new tool, and I just wanted to make sure. Alright, so what I do is I go ahead and I take these. There's one, there's two, and there's three, and I set them upside down. Now I'm going to blow clean and wipe my chuck here. First thing I do is I rotate the scroll and blow out, make sure that all the chips are relieved from inside there. Okay, then I take and I clean each one of the palms of the jaws here. Alright, now that I'm happy with it, there's number 2, there's number 1. Okay, I take the scroll down to the number 1 position where I can see it, I bring it past the opening, and then I engage, and I bring it up. Here's number 2. When number 2 shows up, then you install that. And the same thing with number 3, it's right there, put it in. Alright, now you're joining them all in. Now you can scroll this on in, and we're ready to go. Whenever I tighten on something that's really smooth, I like to rotate it a little bit. It helps align it this way into the chuck, and I go around and I make sure she's snug. And she's running nice and true. As true as I visually know that my chuck does have some run out, and that is really holding it pretty true. Alright, now we need to go ahead and put the angle for our center, and that'll be 30 degrees off of the center line here, the axis of the lathe or the spindle. Now you want to plan out your travel with your compound so that you're comfortable in the full travel of it. Now I know that I set my compound usually equal with the end of it here, and that gives me about half and half of its travel. So I kind of go about halfway in between the length of the cone I need, so that's about 3/4 of an inch. Kind of go in there, and I know where I'm at here. Alright. Give myself some hand room here. Okay, we're going to let her ride right there. We don't need any feed. We're going to be feeding this by hand. Okay, that's just touching off on the edge. We are going to give it a little oil because this material is a little stout. Alright, we're going to give it about, I think that was about 100 thousandths. Now our very first pass there was a little bit of backlash from the carriage and everything else, but also you do have to hold your hand wheel because a certain amount of pushing in this way here causes a little bit of motion this way here on your carriage. My carriage does float really easy, and so it does you do tend to have to hold it in position as well if you're really going to be pushing on it. Alright, so we're getting down there, and I'm going to go ahead and I'm going to crank in about another 100 thousandths here, and we'll get some, you know, roughen some of this material. I'm actually holding the carriage with my thigh, the handle over here, so that I can hold the carriage where it's at for my hand pressure and everything else that's going in here. Alright, we're getting down here. We got about another 200 thousandths on the diameter of the point here, and we're gonna bag it down to about 50 thousandths per pass now. Okay, you're only using a little tiny bit of this, so you can take your time and do your little fine feed here. Once you get up above where you know that you're not going to be running, just, you know, you can hog that material off of there. I mean, it is nice to see a nice shiny full surface, polished and all that good stuff. So you tend to make your whole job look good as well, but I'm just saying the most important part is that very beginning there. Okay. Now, even though it looks nice and it's a nice machine cut and everything else, I want to go ahead and I want to dress this off a little bit. One, when you're working around centers and stuff like that, that's a sharp point. You do not want to catch it in the back of your hand, especially if it kind of pokes into one of your veins there. So I do like to take one of my junk files and give it just a little flat on the end. Then I go ahead and take one of my better files and I just give it a couple draws here. And all I'm doing is removing the little machine lines down in this area right here. Then after that, then I take a little bit of paper and I give it a polish. Now, this was all the work to go ahead and make the part the first time. Now, each time I use this, I just clean the chuck, slide it in, take a light skim, polish it. Light skim, polish it each time I want to use that. Okay, and this is how this one started. And then over the years, this, from skimming it, you come back, and that's why I went ahead and made a new one. Okay, I'm done with this side here, and we're flipping this around, and I decided to go ahead and bring my piece in on my south bend and go ahead and give it a quick face and a center drill, instead of going and pulling that one, doing the center drills, putting the center back in and skimming it. I use my south bend more so than anything else just for second operations. I am mounted on a wooden floor here, waiting to find the right location. I'm going to pour a slab and actually mount this down here, so you can see this thing rock and roll when I kick it on. And like I said, it's I love the machine. It's a novelty piece. The south bend 13-inch, this air is just, it's it's like one of those things you got to have one. Even though this is in pretty sad shape as far as the ways, the center ways for the tailstock are actually worse than the ways for the carriage, but it has an enormous amount of wear in it. And this is going to be a good project, and this is a good candidate for me to go ahead and completely tear this down to parade rest and build it from ground up. And I plan on doing that sometime. Okay, let's rephrase that. I dream of this being a project someday, maybe. All right. really important that both of these faces be perfectly true and everything, so I'm just kind of quickly going across the face here just to get them flat. If anything else, it just makes my project look much better. Alright, this is a number 4 center drill, and I'm just bringing it in and giving about 3/4 of the depth of angle surface right there. Lightly hold it so it gives a nice polish. It's pretty hard to mess up the surface quality on 12L14, which is a leaded stock made for pre-machining. You cannot weld with it, but it does turn really nice. And of course, this is the butt end of that surface in there, which is evidently got some dirt and stuff in there. Alright, now that's hefty. The first one I did a little bit lighter. Alright, we're going to go ahead and get our part set up here in between centers, and I'm going to swing my compound, or my compound back around in the direction that I use it. Now, some people actually have asked why do I run it in this off angle here, and most of the time I want to be set up. This is comfortable for most of my operations as well in this position here, but this angle is always ready and set to go for threading, and I do threading quite a bit. So I like this compound to be set up so that it's prepped for threading, and any project can be coming around and I can be set up all square and for most of my operations, and then I can also drop in the threading tool bit insert, or if I have to do another standard V-shaped tooling of high speed or boring bar or whatever, I'm set up for that angle of approach. And that's why I like to set my compound here at it says 60, but it's actually 30 off of the 90. So I mean, let's just say there's 90, okay, so then you're coming back 30 degrees from that position. And actually I have a little tiny line here that makes it just a slight bit proud, making sure that I'm never light on the back side of the V thread. So when you go to get to the bottom and you do a spring cut, you actually almost are cutting off of both sides simultaneously for the last little spring cut or two that you take on your passes for your thread. Alright, now that we're set up like that, we can go ahead and loosen up our compound. I'm going to pull this holder up right now. And now we're going to go ahead and we're going to set the part in here between centers. I'm going to use my live center here. I bring out the center a comfortable distance there so that I know my carriage and everything else swings where I want to start in the work zone. The starting work zone is at the center. So I want to make sure, and I know how much of this clearance and everything else is in here in relationship to hanging my tools on my holder, just from experience. So either way, so now what I'm doing is, this is 2 fixed points. These will stay like this. Okay, so your part's in there like that. I have high pressure lube, which we're going to be putting on the centers, because even though this is going to have a dog on it and is going to be locked in rotational pattern with the chuck spinning, there is a slight bit of misalignment, no matter how minute that is, whether it's even measurable or naked to the naked eye. or even by an indicator of maybe a quarter thousandths or something like that. This is a very old machine, and the pressure lube actually helps this, and I'm exaggerating, this motion of the contact of the center. You can also have something set up here to where you are purposely putting it off center, meaning you're going to put some kind of a taper into it, so you pre-dial it so that your path is off, your part is held off, so that when your cut comes true down here, you're going to make some kind of a taper cut or a size difference from end to end. You will also be pivoting in one direction, but as it's rotating, it rubs on the whole thing. And the high pressure lube actually makes those two mating surfaces work nicely together.